Okay, hello. So today I just want to give a basic structural overview of what we have so far for the URAP project. Um, this is going to be a very, very long video, maybe even like 20 to 30 minutes. So feel free to skip around for the important parts. But, and obviously we're going to comment our code, but I just thought it'd be good to have a more general overview of what all the files in the project are and what each of them does. And later we can also even look at the inheritance tree for how the classes work. But first, we're using libGDX, which is a framework for programming. So it's not really like a game maker where it has its own special software and you don't really code as much and you really just use a very strict framework. This is a more of a looser framework where you can still code a lot yourself and individualize it, but they program a lot of things for us that we don't have to. For example, there's everything from like math utilities like vectors and matrices to things that handle physics and collisions. Very easy, like rudimentary basic stuff that we are pretty glad that we don't have to program ourselves. It's also multi-platform, so we can get it working on Android and Windows, but for HTML, things are more slow, and we gotta still fine-tune that. And it could be a major concern down the road if we really want to port this to the internet. Anyway, let's just learn how to import the projects into Eclipse. Now, I already have the project, so I'm not going to be able to do it completely, but you just need to know where it is on your computer, where these folders are. And you say existing projects into workspace. I went to file import, and you have to find the folder where all of these are kept. So for me, it's in Windows, and then there's a URAP folder, and then there's test folder. That's where I have mine. And then stuff like this will come up, and you'll be able to check all these boxes and import it. Now I can't because they're already here. I'm going to try to make some references to the code, but if I do that too much, then the PowerPoint is going to be kind of wasted. So I encourage you to follow along with the code, next to you. So overview of the files. The way that this works, and this is one of the times where I will use the code mostly, is that when we want to run this project, we need to use Android Desktop HTML or RoboVM. I mean, for us, when we're debugging, we just use desktop. And if you look at desktop, there's really only one file, and this file makes just like a Windows application, makes a window, and then it just shoves our program into it. And it does that by putting a starter into it. So while we have all these like different projects down here, they really are only just one file. It's like a launcher. And all of our real code is in just this clean fighter file. So the way we debug is that we run this main file, and then when we run this main file, it creates a starter, and this starter, all it really does is when it's created is that it just makes a game screen and sets that as our screen. So basically just we see the game screen. Later on we can have screens that aren't just the game. There could be a pause screen, stuff like that. But it's basically what we see and interact with as the player. And then game screen, then this has all of the stuff that the program actually needs to run. So for example, it renders things and updates things, and just that handles all the gameplay from then on, from after that. And game screen, it's important for two reasons. It shows things, and it also interacts with the user. So when I click on the keyboard to move left, for example, it's the game screen that senses that raw input, and mostly it just passes that raw input to other classes, mainly world renderer and world controller. So anyway, after that we have our world, and if you look at the world class, you'll realize that actually it's all programmed by me. It doesn't have any libGDX stuff in it. And that just contains our player, our enemies, our projectiles, and it passes the update and render functions to these things. And we'll learn more, what that exactly does. Also, world keeps track of whether or not, projectiles are hitting enemies or something like that. Basically, it's where all of our things that are rendered to the screen, that's where they live. We also have world controller that does two things. It calls the update function on world, and it also gets some raw input from game screen. So game screen says, oh man, somebody pressed W, and then passes it to world controller, and world controller says, okay, we need to go left now. And then world renderer does a lot of drawing, and it basically so we have a player walking around on the screen, and the reason that we can see it and the reason it gets drawn onto the screen is thanks to world renderer. And that's actually a very complicated process, but I'm going to try to give kind of an overview of how that works. So it starts in the game screen, and the game screen has this render method that just magically gets called around 30 times every second. libGDX takes care of that, but it gets called around 30 times every second. And 30 times every second, this method gets called, and every time that happens, game screen calls the render method in world renderer and says, hey, you know how to draw things, so you take care of that. So now when we're in world renderer, it has a lot of complicated stuff, but all you need to keep track of is that it has something called a sprite batch. And the sprite batch is basically like pen and paper. So it's this special object that has access to the screen that we need to draw things on, and it knows how to do it. We don't really care how it does it, but I know that if I tell the sprite batch to draw a rectangle, it knows how to place the pixels on the screen in the right way and in the right place. So the way that sprite batch works, though, is that it needs to know what to draw, and in this case we're going to be drawing textures, which are basically images, and it needs to know where to draw it. So which coordinate on the screen, like 5 pixels over and then 20 pixels down, or where do you want it? So now the world renderer doesn't actually do any drawing itself. What it does is it creates the sprite batch object, right? And it gets it ready and it configures it in all the right ways, but instead it just passes it to our world. And if you remember, our world is the one that has all of the enemies, projectiles, and the player inside of it. It passes it to the world and it literally says, hey, draw yourself, here's a sprite batch. It's kind of like if we needed to get everybody's name on a clipboard, and instead of having one guy go around and collect everybody's name and write it down on the clipboard, we're just passing the clipboard along and saying, hey, why don't you do it yourself? So what the world object does is that it says, okay, well now I have a sprite batch and I know I need to draw myself. The world object has access to all of our objects, all of our phys objects, which are just like I said, the enemies, the projectiles, and the player. And then it tells each of those objects to draw themselves. And all of those objects have a special draw self method. And in the draw self method, they have access to the sprite batch. So they just give the sprite batch all the information it needs to draw them. So it has to give them a texture and it has to give them a position. But right now, let's figure out how they get their texture. Okay, so each of those objects, when they're first created, they load their texture. So they say, okay, my texture is this image on the computer. And libGDX knows what folder to look at on the computer, and then that folder has all of our images. So, how does it know which file to look for? Well, each of these objects has its own special method that says, okay, it's called a get image name method, and it says, okay, well, I'm a soap object, so you're going to want to look for the soap.png file. And so for soap, for example, it has a get image name method that returns soap.png. So when a soap object is created, it loads its own texture once and doesn't need to do it ever again. And it loads that texture as being soap.png. It's a picture of a bar of soap. And then now we're back to the draw self method in one of these objects. For example, let's say it's a bar of soap. Its draw self method says, okay, well, here's my texture that I loaded a while ago when I was first created. And then also, here's my position, because every object on the screen already keeps track of its position. So it says, draw it at this x coordinate and this y coordinate, and here's a texture. And then Sprite Batch knows what to do with that information, and it draws it on the screen in the right way. So a lot of this stuff is abstracted away, and we don't really know the nitty-gritty details, but we don't really care as long as it works. Another thing to keep track of is how to update things. So now updating, the way that works is it's not necessarily just drawing, but if we have a player going left at 5 pixels a second, well, the update function is the reason that every second it's going to be 5 pixels to the left. So for example, a physical object has an update method that every time you call it, it says, okay, what's his velocity? Okay, well, using that velocity, change its position by this much. And the way the updating starts is back to that render function on game screen. That's the function that just gets magically called a bunch of times every second. So we already said that the first thing that method does is call the render function in World Renderer, but it also calls the update function in World Controller. And World Controller, its update function, mostly what it does, I mean, of course, it processes input that it has, but we don't need to worry about that yet. But the important thing it does is it calls the update function in World. So it's basically just passing the buck next down to World. And then the World's update function, that does two things. First, it checks to make sure, okay, are any of the projectiles hitting any of the enemies? That's pretty easy to do. All it does is it just looks at, okay, well, what are the bounds of every one of these projectiles? What are the bounds of every one of these enemies? It compares them, and if they are, intersecting, then it has its own special method to take care of that. But the second thing it does is it calls the update function on every single object that it has. So it calls it on player, calls it on every projectile, calls it on every enemy. And then each of those, they have their own special update method. So they can do whatever they want. But in practice, what they all do is that they update their position, their velocity, and their acceleration just based on what it is right now. So they're going to make their position go left if their velocity tells them to go left, and they're going to increase their velocity if their acceleration is positive, all that stuff. And then, of course, later, we can add on to that. So if we have something complicated that, say, for example, we have a certain enemy that looks for the player and chases the player, every time we call the update function, we could have that enemy find the player and then set its velocity so it's going towards the player. I mean, the possibilities are kind of endless, but just it's limited by creativity and whatever else we can think of. Okay, so now that we have rendering and updating done, I mean, I know it's very complicated and tiresome. We will soon be over. But now let's figure out what happens when we process input. What happens when I press the W button and I know that it needs to make my player go up a few pixels. So how does the game know how to do that? Well, again, like everything, it starts in our game screen class, and that receives raw input. So it receives, okay, the user pressed W, but of course that doesn't necessarily mean go up. Like, we don't really know what that means. W, the game itself can't know what to do. So what the game screen does is that it interprets that. It interprets the input into something meaningful, such as the up button has been pressed or something like that. And what it does is it passes the meaningful command to world controller. So it tells the world controller, hey, somebody pressed the up button or somebody pressed the fire button. It doesn't say somebody pressed spacebar or somebody pressed W. And our world controller keeps track of if the player has pressed the up button or the fire button and all that. And every time it updates, it processes that input. So if the up button has been pressed, it makes the player's velocity go upwards. Or if the fire button has been pressed, it does its own special things. Okay, so now I'm going to go through an overview of the classes and the inheritance structure. So now this is kind of complicated. And like a lot of this stuff, you don't really need to know exactly everything, but this is like a very complicated guide over everything, so that when you need to know a little something, you can use this as more of like a reference. So anyway, all of the objects that we made, they are pretty much always inheriting from physObject, which is short for physical object. So all of these guys have all of the stuff that I've written there as we talked about it. They know how to update, they know how to render themselves onto the screen, but they're very basic. But these are basic things that we know that every object in our game needs to be able to do, like collision detection or keeping track of its position, stuff like that. So now we have a projectile. Projectiles inherit from physical objects, which means that they can do everything that physical objects can do, but they override some things and they add some new things. So projectiles, for example, they add something new to all of this, is that they know what to do when they hit an enemy. So say they intersected an enemy, the world object that they're in says, hey, you just hit this enemy. So that projectile's hit method says, okay, well, is the enemy vulnerable to me? So for example, poop is vulnerable to soap. And if it is, then I will deal a certain amount of damage. And that amount of damage that each projectile has depends on the projectile. And if we make a class that inherits from projectile, such as if I make a soap object, which inherits from projectile, I'm going to have to say, okay, well, each soap object has a damage of, say, 50 points or something like that. So another thing that inherits from physical object is a living object. And this does everything that that physical objects can do, but it keeps track of some extra stuff like health and dying, stuff like that. And an enemy inherits from living object, meaning that it has all of the methods that we've talked about so far for physical objects and living objects. And an enemy is very basic. There's literally like one method there, and since it's an abstract class, it doesn't even implement the method, meaning it doesn't even type code. It just says that anybody who inherits from enemy needs to implement that method. So for example, and the method is vulnerable to. So every enemy that we define needs to figure out a way to say if it's vulnerable to a certain type of projectile. So for example, when we extend this class to poop, which is one of our enemies, its is vulnerable to method says that it is vulnerable to soap. So every time it hits a soap object, that soap projectile knows that Okay, well, if this is poop, that thing is vulnerable to me, so I will deal damage to it. And another thing that inherits from living object is the player, which doesn't do a lot as far as health stuff goes, because all of that was taken care of in living object. But what it takes care of is pulling, is basically like firing. So I mean, in the PowerPoint, that you can read exactly like how things are fired and whatnot, but basically it contains a weapon, and every time it updates the weapon too. So it updates all the stuff that physical objects do. So position, velocity, blah blah blah. It also updates its weapon. So if its weapon needs to reload for 5 turns, it will update 5 times without firing, and then fire on the 6th time or something like that. Okay, so that was a very, very long, complicated video about what the project looks like so far. I will have, documentation and more stuff like that, but this video is really just kind of like a last-ditch solution if something doesn't make sense. And you should really look at this video in parts and say, okay, well, I care about how this project handles input, so I'm going to just watch that segment. The whole thing is very, very long, and I wouldn't expect anybody to go through it all at once, without being very, very annoyed. But overall, I think that the project is going pretty well so far. And we can only really improve the structure of this as we go along. Okay, well, anyway, that's it for now. And until next time, we're just going to be working on some documentation and simplifying the structure and getting rid of things that we don't need.